RETScreen Expert, Tips and Tricks, the Building Energy Model, presented by David Elfstrom. I'd like to show you how I use the Building Energy Model with a real-life example. First, I'll gather some information using measurements in Google Earth Pro. Next, I'll create a building model using RETScreen Expert's Archetype and look at how the archetype compares to the benchmarks. We'll modify the archetype to better represent our building and compare with actual utility data for the building. Finally, we will modify the climate data with the weather data during the period covering the actual utility data. Let's start by gathering some information from Google Earth Pro, a free Windows-based program that allows 3D measurements of buildings. I'm typing the building's address into the search box. To the right, I have started a spreadsheet file to record some key measurements needed later for the building model. Click on the ruler icon in the toolbar, shown here in red, to bring up the ruler window for measurements. We'll start by measuring the heading for the building north. I've made a mistake here. The heading line should be drawn starting from the south and pointing towards the direction of building north. The actual building north should be 345 degrees, but we'll keep the 253 degree number and see what effect this has later on. Use the scroll wheel to zoom, click and drag to pan, and shift-click and drag to orbit. Click on the 3D path in the ruler window and click on the start and end points of a line to draw it. Let's orbit around using shift-click and drag to make sure the line is where we want it in three-dimensional space. The width is 133 feet. Now for the height. Slightly off from vertical, but close enough. The height is 127 feet. And the depth is 62 feet. Count the number of floors. 14 floors. Let's guess at the number of suites. On the north face, I think it's 1, 2, 3, 4. On the south, it's 1, 2, 3. So let's say 7 in total. Seven suites times the number of floors is 98. The perimeter is 2 times the sum of the width and the depth. The area of a single floor is the width times the depth. And the gross floor area is the floor area times the number of floors. The north or south wall area is the width times the height. And the east or west wall area is the depth times the height. Finally, the volume is the floor area times the height. Over to RETScreen Expert now, where we'll start a new project using the Virtual Energy Analyzer. Select a residential apartment building, high-rise, and enter the address. RETScreen is showing our facility location indicated by the house, and the climate data location indicated by the globe. It looks like it might be using a location near the water, so let's zoom in and check. Looks okay. It's chosen the one near downtown and not on the island. Let's move on to the Facility tab. The Archetype visually matches our building. Change the units from meters to feet. The model RETScreen created has a floor area of 148,000 square feet, while ours is 115,000. On the Energy tab is the whole building model. Click Comparison to look at the model's energy consumption. The whole annual fuel consumption is 5.8 gigawatt hours, which is the sum of the natural gas and electricity energy, when converted into the same units of energy. Back on the Facility tab, I'll switch to the Level 2 analysis. Here we see the same values for electricity and fuel consumption as in the base case in the building model. Here they are in the building model. Switching back to the Level 1 facility analysis, let's change the units to metric to compare against the benchmark database. I've already applied filters for Ontario, residential, and multi-unit housing. The numbers are very different from one another, and we would have to look at the reference to find out more. It ranges from a low of 97 to a high of 274 kilowatt hours per meter squared. Over in the benchmark section, these numbers come from national averages in Canada and the US for the facility type. The base case intensity was generated from the Archetype energy model, and the proposed case represents a 33% reduction, also modeled. Expanding the benchmark to all of Canada, there are plenty of average intensities to select from and compare to our building. Let's switch back to square feet. And now we'll put our measured facility size in the benchmark. RETScreen calculates the new benchmark based on the facility size, and it is 4.5 gigawatt hours. Switching to the energy model and using the comparison feature, we see the new base case of 4.5 gigawatts is now in there. We want to adjust the size of our model to make it close to the plan. Starting off in the building envelope, let's change the building north for both the base case and the proposed case. Next, I'm going to change the window areas to percentages before I change the wall areas. The window area percentages are approximately the same as what our building has, so we'll leave them alone. Change from square meters to square feet, and then put on our numbers. We'll leave the R values the same. Then, click the Copy button for the proposed case. We don't need to change the window values, and we'll leave the solar shading the same. The roof area is the same as our single floor area. The perimeter is used to calculate the foundation heat loss. Oops, I forgot to copy over to the proposed case. I'll come back later to fix that. Next up is the air leakage. Here it is expressed as an air change rate, so we will update our volume. Let's fix that perimeter I forgot to copy earlier. Domestic hot water use will be lower, so we'll change the number of units and use the values RETScreen estimates. I'm going to lower the proposed case accordingly. We're only 6% higher, which is pretty good. One really large load is ventilation though, so I want to adjust it. I'll use 80% of the original value to account for the smaller building. I'll do the same for the bathrooms, again taking 80% of the original values. Checking the comparison again, we're now 4% less. I'd say that's close enough. We could change the corridor value, but it's small to begin with. Let's copy the values from our model over to the facility benchmark page. Let's copy the square feet over from the facility benchmark page. Let's have a quick look at the effect of building north orientation on the total energy consumption. I made an error pointing the long edge of the building west at 253 degrees instead of north. So I changed it to the actual building north. On a single window, the difference might be a lot, but on a whole building, not so much. The total energy reduction is just 0.5%, both for electricity and for natural gas. It so happens that I have actual utility data from last year, so I'm going to enter it now. Well, it looks like our real building is performing quite a bit better than the base case model. Could part of this excellent performance be explained by last year's weather? Let's try it and see. Remember though, there's plenty of non-weather related loads, such as hot water and lighting. Moving to the performance section, I'll create a weather file and download recent data. I'll need to create the heating degree days and cooling degree days. Group by month. Speeding this up, I'm copying the year of weather data over to a spreadsheet and reducing the number of digits displayed. Now I enter them by hand on the climate location. This was a 5% milder winter, but a 44% hotter summer than the climate data used by the model. Despite the large increase in cooling degree days, the total electricity went down by 2% and the gas use increased by 4%. Why? I'm not certain, but there are some strong interactive effects in the energy model. So is a real building performing significantly better, or is the Archetype model intentionally an underperforming building? I think it's a bit of both. There's a wide range in the energy intensity benchmarks, and in real-life buildings as well. We can get drastically different results by changing only a few parameters. These are, for electricity, constant running loads, such as motors for fans and pumps, and computer servers. Lighting is another factor, LED versus fluorescent, especially in commercial buildings. For natural gas, ventilation rates top the list from both mechanical air changes and natural air infiltration. A small change in the temperature set points and schedule will also have a major change in the predicted energy. And finally, the equipment efficiency can result in some differences too. My advice is, don't knock yourself out trying to get a building model to balance with the actual consumption. Remember, RETScreen is a screening tool, not a detailed simulation. The goal is to have a model that allows for improvements to be quickly screened for basic financial feasibility.